Hey everyone, I'm going to do another tutorial. This one is how to make a simple tic-tac-toe game in Unity. This is for mobile, which is why my my view is this 400 by 800, which is just a very general um, mobile view. Um, I've already made tic-tac-toe, and I'm just going to show you real quick what it looks like, and then we'll go through how I made it so you guys can see how to do it. So it populates the grid with these square buttons. I can click these buttons and it'll either be circles or X's. It starts with circle, X. I'm just gonna win real quick with circles, and it says who the winner is, and then it restarts the game. That's pretty much how it works. It should work for X's as well, and that's pretty much it. So now I'll go through how I made this. So I'll create a new scene, and I'm going to save the scene as Tic-Tac-Toe tutorial. Okay, so first I want a canvas, because this is going to be a UI version of Tic-Tac-Toe, which means it's going to be using the user interface entirely. So I'm going to need a canvas. And then inside that canvas, I'm going to want some background. Usually I use a panel for that. So I'm going to create a panel. It's already created inside the canvas. Make sure it's a child of the canvas. I'm going to name this background. I want it to stretch the entire canvas, so everything in this rect transform is fine. I do not like the color. I want it to just be a solid white. And I also don't want any transparency, so I'm going to make sure there's no transparency by setting the alpha value to 255, and all I did was change this color. And then it's still a little gray, so I'm going to click on this background, and this is the default sprite that Unity uses for panels. I don't want to use that, so instead I'm just going to switch it to none, which is going to give me a straight white background. That's all I need to do for the background. Now I want to create my grid. So my grid is going to be another panel, and I'm going to call this board. But I don't want this board to stretch the entire screen. I want it to be a square. And based on what I did before, a good number was 350 by 350. Let me change the color a little bit. Let's actually just make it black, and then I'm going to get rid of the alpha value. And now you can see I have this this black board, which is square is best. You can make it whatever you want, but tic-tac-toe is generally 3 by 3, and it's generally square. I want to make sure that this game also scales or resizes well. So right now, if I were to switch, you can see that is not what I want. I don't want it to get smaller when I switch to this other resolution. So let's make sure it resizes well. So first I'm going to go to the canvas and go to this canvas scaler component. And instead of a constant pixel size, I want to scale with screen size. And I want to set my reference resolution to my current resolution, which is 400 by 800, which you can see right here. If you want to add a resolution, you just click this plus. You can type in whatever you want. I'm just going to call it new. And then you just type in a width and a height. And it will automatically switch to that, and then you can switch back and forth. Now you can already tell that just by doing that, the middle board now is scaling. Just to make sure it scales well with different forms of scaling. So this is kind of, this other right here is very similar in that the width is much smaller than the height by a factor of somewhat close to 2. This is obviously a lot or a little bit higher than a factor of 2, but just to make sure that it scales well, even if the factor is much different, the multiplier factor. So I'm going to make sure these anchors are on the corners for this board. So I'm going to go back to my scene view so you guys can see where the anchors are right now. That's what's in the center, the exact center. And something to keep in mind, if you want to set width and height, the anchors need to be not on the corners. So I generally just put them back to the center in order to set my width and height. And then with UGUI tools, I just select anchors to corners, and it moves those anchors right to the corners. And now you can see that there's no option to change width and height anymore. That's because now the anchors are in the corners, so width and height doesn't really make sense as a form of measurement. Instead, it would be how far away you want it from the anchor to the left, how far away you want it from the anchor to the top, to the right, and to the bottom. In this case, because the anchors are on the corners, we want this to all be 0. So now, with that done, and for the background I don't need to do anything because it's already stretched completely. And that means the anchors are already at the corner as well. You can see that. With that done, I can start switching, go back to game view and start switching my resolution. And you should see now that it actually scales the board to the resolution. If you wanted to keep it a perfect square, you don't have to do this. You can set the board back to just the center, and you'll see that it stays a square and still resizes. So keep that in mind. I think in this case, because Tic-Tac-Toe is a square, we're going to leave it this way, but most of the time it might be better to stretch a little bit. But that is up to you guys. I'm going to leave it like this. Okay, so now I'm going to, I need to populate this board. And I need to make sure this board puts everything in the right position. So just to start, I'm going to add to this board a grid layout group. Now you may have worked with vertical or horizontal layout groups before. A grid layout group is basically a combination of those two. It can control the layout in both the vertical and horizontal direction. And so if I were to add some objects to this board, let's quickly add a button, because we will be using buttons a lot. You can see as soon as I put it as a part of the board, it resized it and it moved it to the top left. That's part of the grid layout group. And if I copy this a bunch, you'll see it also moves them and orders them. Now with the horizontal and vertical layout group, you can pretty easily make sure that the object is centered and in the correct position. That's a little harder to do with a with a grid layout group, but we can do it through code. So I'll show you guys how to do that. And the way I'm going to write the code, it should resize no matter what resolution we're at, and it should fit inside the square. So I'll show you how to do that, but you should have 9 buttons because that is how many squares there are in Tic-Tac-Toe. And this is basically how we're going to create Tic-Tac-Toe, is just using these buttons to let the player interact with the Tic-Tac-Toe game. So I'm going to leave this the way it is now because we're going to change it through code anyways. Same with this grid layout group. And let's start going to the code. So I've already got the script I called Tic-Tac-Toe tutorial, or toot. I'm going to open it up. Here it is, still a blank script. So let's start going through how to program this. So I'm going to start by creating some public variables. We're going to need the grid layout group, and I'm just going to call it board. And now you'll see it's red because it doesn't know what a grid layout group is. That is because we did not include UnityEngine.ui. Great. Okay, see, now it knows what a grid layout group is. We are going to now add a rect transform, which is basically the same thing as a transform but for UI objects. And we're going to call this board size. This is basically what we're going to use to figure out how big the board should be so that we can place the buttons correctly on the board. And then we're going to need a list of the buttons, or an array of the buttons. I'm just going to call this board buttons. And board button is another script that I've created. I actually want this to be board button 2. And we're going to need these buttons to loop through them later and check the game state. So the point of this, which we'll do later, but the point of this is to check if there's a winner, and if there is a winner, reset the board state, stuff like that. We could just use the normal button. There's already a public variable for button. But in this specific case, I'm going to want to do something whenever the user presses a button, and I want each button to have their own script and also have their own information about what their state is, so if they've been pressed by X or O, stuff like that. So in this case, I'm going to want to add a script to each button, and this array is going to access that script from each button. So that's why I'm doing it this way. And then I want this class, this Tic-Tac-Toe tutorial class, to be a singleton, and a singleton basically means that this class should only be in the scene once, and if it's in multiple times, then the second one found should be deleted. So a singleton just makes sure there's only one instance of Tic-Tac-Toe tutorial in the scene, and the reason why I want this is so that I can have a global variable that other scripts can use, and they can use it because they know there's only going to be one version of that global variable, which is going to be in this singleton version of the script. So to create a global variable, I'm going to use the keyword static, and I want this global variable to be the type of this script, which is Tic-Tac-Toe or tutorial. And then I'm just going to call it instance because that's pretty much standard practice. Instance is just this instance of the Tic-Tac-Toe. Okay. So then in start, in order to create this singleton, I'm going to just do some quick checks to see if the instance has already been instantiated, and if it hasn't, I'm going to set this object to instance, and if it has already been instantiated, I'm just going to delete this object that has the script. So if instance equals null, so this means no tic-tac-toe toot in scene yet. So if instance is null, we're going to set instance to this. Else, so this means instance is not null. Or maybe a better thing to say, what instance already exists in scene. We want to say destroy this .game object. So make sure you destroy the game object and not just this, because if you say just destroy this, it'll destroy the script but not the object, and then you might have a blank object in your scene just doing nothing and using up your processing power. So there's no point. So just make sure to destroy the game object. And then if you planned on having multiple scenes with this object and you wanted it to persist from scene to scene, because it's a singleton, you want to make sure that it only appears once. So in this case, since I've made it a singleton, it's a pretty nice object to make persist. But I don't have multiple scenes, but if you did, then if you wanted to persist, you would just say don't destroy on load, and you would say this, or this dot. No, you would just say this. So don't destroy on load means that when it's loading a new scene, it won't destroy this object, which is how Unity switches scenes. They destroy everything, and then they instantiate the new objects. So for instance, if I had this object in this tic-tac-toe scene, and I reloaded this tic-tac-toe scene with don't destroy on load, it would now have two tic-tac-toe tutorial objects because one of them was from the scene before I loaded the current scene again, and the other is from after I loaded the scene again. And normally that would be an issue, but because we made it a singleton, it'll just delete the old one, or no, it'll just delete the new one, and it will keep the old one, because the instance will not be equal to null. I don't have more than one scene, so we don't need this, so I'm not going to use it there. Okay, and then we are going to want to get these, or set up this board buttons array. So we're just going to get component in children, board buttons, or board button toot. And this should return an array of all of the board button toot objects in our, it should say get components in children. It's components because we're looking for more than one. And we're looking for more than one because we want it to be an array. So this will return all of the children of this object, and this is going to be attached to our board. So if I go back to Unity real quick, the script, we'll give it a sec to load. Okay, so we're going to attach that script tic-tac-toe toot. We're going to attach that to the board. So each of these buttons is the children of the board, and so these board buttons are going to be these children basically. We made it public. Let's go back here real quick. We made it public, which is why it's showing up in the inspector. We don't need it to show up in the inspector, so we're just going to make sure it's private. We can either make it private or hide an inspector. If these board button toots are going to be accessed, or if this specific variable, board buttons, are going to need to be accessed by another script from this instance, we need it to be public, and then we can use hide and inspector. If we don't need to access these board buttons from another script, we can just make it private, and then it won't show up in the inspector. I'm just going to make it private because we shouldn't need to access it from any other script. Okay, so we'll go back to inspector real quick so you can see that once this loads, this will disappear. There. Okay, I'm going to quickly fill in this stuff too. The board is itself in this case, and the board size is also its own rectangular transform. Okay. So then now, I think we've pretty much finished the start for now. Let's start programming the board size. So I'm going to get rid of this real quick, and I'm going to create a new function with void, which means it won't return anything. And this new function will set up the buttons to be the correct size based on the board. So I'm going to need the width and the height of the board, and since we already have a rect transform, and a rect transform, like I said, is basically the same thing as a transform. It holds information about the width and height of the board or of the panel that we want. So if I go deeper into this rect transform, it has rect, and this rect has a width and a height. So I'm just going to be, this is how I'm going to be grabbing the width and the height. For a normal transform, it won't have this width and height because it's not a rectangular transform, and so you would have to find a different way to figure out its width and height. It of course still has information about its position, which is also what this rect transform has. But just keep in mind that this won't work unless you're using a UI object. UI objects have rect transforms, and game objects, regular game objects, have transforms. Okay, so I'm also going to base all of this sizing based on the variable spacing, which if you go back to the grid layout group, this is the spacing. And what the spacing does is it's basically the space we want between each of these buttons. So I'm just going to use this spacing to set up this the spacing that I want. Now you can see this already looks kind of okay, but it's not centered. It probably won't resize super well. So just to make sure it's exactly where I want in case I change the canvas to, that's why we're doing this part in script. It's also just a good way for you guys to learn a little about Unity scripting. So because I'm using that spacing, I need to grab that spacing, those variables, so I know what the user has put in the editor, or what the developer, I guess, has put in the editor, and then this will allow me to choose my own spacing nicely. So I'm going to grab the X and the Y spacing, and that's mainly all the input I care about from the user, and now I'm just going to create the board. So board.cellSize, this is this variable right here. If I change it real quick, you can see what it looks like. So we want to set this cell size. To do that, I'm going to use a little math. So we're going to use a vector 2 because that's what a cell size is, a vector 2, just an x and a y coordinate. For the x, we're going to take the width, and put this in parentheses. We're going to take the width, we're going to divide it by 3 because there are 3 tiles, and then we're going to subtract the spacing. Make sure you subtract the spacing after you divide the width, not before, because we don't, it's going to create a weird, you're basically dividing the spacing by 3 as well if you do it before, and we don't want to divide the space by 3. So make sure you do it after. And then it's almost the exact same thing for the y, except we're using the height instead of the width, and we're also using the y spacing, if for some reason they want to space the y differently than the x. Okay, and then we want to add a little padding. If I go back here, padding, oops, padding on the board is this left, right, top, and bottom. It's how far you want it to move left or right, or move away from the margins, I guess. Just gonna put it back real quick. So we also want to make sure that happens based on the spacing. So with pad, or just basically the padding for the left and right, and this needs to be an integer because padding is only integers, it can't be decimal. And so I'm going to use math f dot sealed int. This will just turn a float into an int. and I'm going to give it the X spacing and divide that by 2. We're dividing it by 2 because it's doing both the left and right. If we don't divide by 2, we're basically doubling the spacing on the outer edges compared to the what's used in between each tile, which I don't want to do. So I'm going to divide by 2. And then for the height, it's almost the same thing, except instead of using X space, we use Y space. Okay. So, and then finally, I'm going to add this padding to the board. So I created these variables, but they're not actually connected to the board yet. So I'm going to create a new rect offset. And this rectangular offset is just what's used for padding. You can see that that's just the type, the game object type. You can look up what a rect offset is if you want to know more. Basically, it's just going to take 2 x coordinates, essentially, or 2 horizontal coordinates, the left and right, and then top and bottom. But since we've already calculated the same number for left and right and top and bottom, you would just say with pad, you can see it says left, right, top, bottom, height, pad, height, pad. And there you go. So now we've also got our padding. So that should pretty much be it to make it create the board nicely. So now I'm just going to call this function and start. If you want the board to update dynamically, you could call this an update, but or a better way would be to call it whenever the resolution changes. Because technically in this case, if I'm doing it in start, if I start the game and then I change the resolution, it won't know to change the board size again. For this case, I'm assuming that the device the person is using, the mobile device, you can't change the resolution of the application, and so this won't be an issue, but just something to keep in mind. So now I'm just going to hit play, and you can see it nicely moved everything into place. I could change the spacing if I want, and you'll see, well, I need to do it outside. Here's what I was talking about. I've already hit start, and so it's not going to adjust. So I'll change it to 10. That looks good too. Maybe I want to change it to 40. And you'll see it, oh, I only changed one side to 40. That's why it looks so weird. Anyways, so you can see this is kind of how it works. I think I'm just going to go back to 10. I think I just selected 10. Yeah, that kind of feels like tic-tac-toe. Okay, cool. So that's how you make the board. And now I'm going to go through editing these buttons.